Hello, this is a question from the 2025 complex number examination 91577. So 91577, 2025. It's question 1. I suspect it's probably designed to be the excellence question. And in my previous video, I said that this question was problematic. I think that's being kind. In fact, I would go as far as to say the question is very, very poor. As written, it doesn't have an answer. But worse than that, it encourages students to use a formulaic approach to get an answer in the desired form without thinking about the consequences of the process they're doing. As I said, this question doesn't actually have an answer. There is no equation of this form here that describes this locus. It sort of gets close, but it doesn't. There's a big problem. So let's just start by reminding ourselves what a locus is and what the bits in this formula that is given in the question describe. So a locus is basically the set of points that satisfy some condition. The condition can be written as a formula, as we've got here, or it can be written in words. And I'd like to start with just look at how we might write this formula in words. And the thing to notice, or remember, or recall, or have done some work and discovered, is that z minus 5i, the modulus of that, represents, or is in fact, the distance from some point z to 5i. Let's look at this in a picture. So if we've got our point 5i up here and we've got some point z, which we can always write as x plus yi, then this distance we can calculate using Pythagoras in a right-angled triangle here. So we've got a distance x along the x-axis, and we've got a distance y take away 5 on the y-axis or imaginary axis, and that means that we would get x squared plus y minus 5 squared. The square root of all of that will tell us this distance. So any formula of this form represents a distance from some complex number. What about z plus 5i? Well, we can just rewrite that as z minus negative 5i. So this is simply the distance, choose a different color, the distance from negative 5i. So we'd be calculating this distance up here. And again, it's going to be x along here, but down here will be y plus 5. And you can do the square root form, x squared plus y plus 5 all squared. So putting all that together, the formula in the question, modulus z minus 5i minus modulus z plus 5i equals 4, is the same as saying the difference that's the subtraction, in the distances to 5i and negative 5i respectively, I suppose, to get them in the correct order, is always 4, is equal to 4. So let's think about that, and I ask you a question. If the distance between these 2 points is always 4, so let's draw a graph. We've got 0.5i up here, we've got negative 5i down here, and we've got some point in the plane, in the complex plane, and the distance between or from each of these points, and we subtract them, we always get 4. Is the point, or are the points, let's make it, are the points on the locus closer to z equals 5i or z equals negative 5i? And the answer to this question, I think, is straightforward, because we've got a distance of 4. So the only way you can get something 4 is if we take a bigger distance and we take away a smaller distance, we will get something that is positive. If these were the other way around, then we would get something negative. So that means there's a bigger distance from 5i than there is from negative 5i. So that means we must have a point that's closer here. And more than that, any point in this whole upper half plane can't possibly be closer to negative 5i than it is to 5i. Every point up here is closer to 5i, every point down here is closer to negative 5i. So that means our locus has to lie entirely within this lower half plane. We can do better than that. We can actually find one point quite easily. If we take the point here, negative 2i, we can see that the distance from here is 5 minus negative 2, which is equal to 7. And we can see the distance here, negative 2 minus negative 5, same as adding 5, is 3. And there's a difference of 4. So this point here, change colors again. So this point here at 2i is on the locus. And I think without doing all the calculations, you probably can't see it all, but you can imagine that the locus is going to be some sort of curve that fits in here. I won't go into details as to how to reason that it has to be a curve, but we can see that, I think. But the important point at this point is that this curve lies entirely in the lower half plane. There are no points up here. Nowhere up here. Any point up here is automatically excluded. Automatically excluded. These points are all closer to 5i than to negative 5i. So if I take that distance and take off this distance, I'll get a negative answer. Can't possibly be getting 4. So I want to leave that now, so that, but the point is that the equation in the question represents a set of points that all lie in the lower half plane. Now I want to turn our attention now to the the form that they require the answer to be. So they tell us that they want to write a Cartesian equation in the form ay squared minus bx squared equals k. And the problem with this here is that this is symmetric, and in particular it's symmetric about the x-axis. And this is something that you've seen before. So some other symmetric examples that Year 13 students would be familiar with. So one, just the parabola, y equals x squared. So you know that comes down like so. Excuse my poor drawing skills. But what that means is if we've got a point over here that has coordinates x, y, we necessarily have a point over here, negative x, y. So there is a symmetry in this case about the y-axis. It's a mirror line. These distances should be the same. And that comes because of this x squared term. If we square negative x, we get the same thing as if we square x. So any point xy that satisfies an equation of this form is going to have a mirror point, negative xy, that also satisfy that form. The second example I'd like us to consider with the symmetry is circle. And you'll be familiar that like a basic circle centered at the origin has the form x squared plus y squared equals r squared, and we can draw a picture of that. So we let's try and get something that looks roughly like a circle. We get a circle around here. The radius is r, but the crucial thing is if we've got the point xy that satisfies that, we will also have negative xy that satisfies it. We'll also have symmetry down this way, x negative y that satisfies it, and we'll have symmetry over this way, negative x negative y satisfied. So if we find one point on the circle, we automatically can find 4 more points, and that comes because both x and y are squared here. So if you take the negative of them and you square, you'll get the same thing. So any point of this form that satisfies this equation means that these other 3 points that have symmetry by reflection in the x and y axis satisfy this equation. And that's pretty much exactly the same as we have in our question here. The question says ay squared minus bx squared equals k. K is a constant, r squared is a constant, so they're similar. We've got x squared up here, we've got x squared down here, we've got y squared up here, we've got y squared down here. There's constants in front, the constants up here are implicitly 1. There's a minus sign in between, but that changes nothing. The thing is that anytime if we have a point xy that satisfies this equation, that necessarily means that negative xy will satisfy it, which means that, and also means that x negative y will satisfy it, and also means that negative x negative y will satisfy it. So let's draw a picture yet again. So the question, the form that they want you to give an answer in, if we have a solution xy up here, not drawing the picture, but we know that the point x negative y down here satisfies. We know that the point over here negative x negative y satisfies this equation, and we know that the point up here negative x positive y satisfies this equation. So we've got these 4 points, which is exactly the same as we've got on the circle. We don't know how they connect together. It turns out, as we saw partly before, that the curves this time take this sort of form, and they're actually a familiar curve to you, although you would have seen it mostly in a different context. They're hyperbole. But we also saw that every point in this upper half plane is excluded by the equation in the question. So an equation of this form always has this symmetry, so must include both parts. The equation in the question doesn't have that symmetry, so it can't have this upper part. And therefore, and I don't think I can emphasize this strongly enough, therefore z minus 5i, take away z minus plus 5i, the modulus of those two things equal to 4, has no Cartesian equation in the form a y squared minus b x squared equals k. This equation is symmetric it's about both axes, but the one that concerns us is the x-axis. This equation is asymmetric about the x-axis. They're related, but they're not the same. The question could be fixed if the question said modulus of z minus 5i take away the modulus of z plus 5i equals 4, but instead of just 4 they wrote plus or minus 4. That gives us both branches. But the question as written only gives us one branch, or another way that they can fix this is 5i, that's the equation they had, but the answer is, when it has the symmetrical form, will include the values where this is negative 4, so you could put an absolute value around this whole thing, and that would solve the equation as well. I suppose you could also solve the equation by getting your answer a y squared minus b x squared equal to k, and then specifying that y has to be less than, it's never actually equal to, but has to be less than or equal to 0, and that would exclude the top part. But this equation has got this extra condition, so I would say it's not in the form that's required. Let's just look again though at how you get a solution. So what they're wanting you to do is to put z equal to x plus yi. It's the common thing to do when you're solving one of these locus questions. And you put that into the equation, modulus of x plus y minus 5i, take away modulus of x plus y plus 5i, has to be 4. These moduli are effectively square roots, so you can write this the square root of x squared plus y minus 5 all squared, square root of that sum, equal to, I'm going to just shift this onto the other side at the same time, the square root x squared plus y plus 5 squared. Then if we square both sides, we lose the square root on this left-hand side. I'll take the liberty of multiplying out that square root, that squared term as I go. If we square this side, you have to square the first term. You get a mixed term, which will be 2 times 4 times the square root. And then plus when you square this, you get rid of the square root. And again, I wanted to write that out, and I'm going to need to be more economical with my screen space. So that's x squared plus y squared plus 10y plus 25. And we see we can get some cancellation here. We've got x squared on this side, we've got x squared on this side, we've got y squared on this side, we've got y squared on this side, and we've got 25 here and 25 here. They will all cancel. If we shift all of the terms to the left-hand side except the square root term, then we'll get minus 10y. This is plus 10y, is going to become minus 10y. 16 will become minus 16 and equal to 8 x squared plus y plus 5 all squared. We can divide through by 4 to make these numbers a little simpler, and then we need to square again. If we square this side, we get 5 squared is 25, negative 5 squared the same, negative times negative is positive, 5 fours are 20, there's 2 of those, so it's 40y plus 4 fours are 16 equals 2 squared is 4, get rid of the square root, x squared, and I'll again expand out this bracket. I didn't write the y squared in here. 25y squared when I square that. And now if we collect together terms, we've got 25y squared here, and we've got 4y squared on this side, so it's going to become 21y squared. We've got 40y, and we've got 4 times 10, that's 40y. They will cancel. And we've got 4x squared here, that's going to become minus 4x squared. And we've got 4 times 25 is 100, take away 16, that's 84. And we get an equation in the form that they want, but this equation, as we saw, is it is symmetric. What that means really is it's got additional points that do not satisfy the original locus, and that's a problem. And how does that happen? It happens because these squaring processes introduce potentially extraneous solutions, and this is something that students should be aware of. In this case, the extraneous solutions is a whole branch of the locus that doesn't exist in the original question. So this is the original, and this is these bits are extraneous. But this equation has both branches, and therefore I say it's wrong. Anyway, thanks. Hopefully that makes some sense. Students should be able to identify when you might get extraneous solutions and then be careful with their work. I think if you draw a picture at the beginning, you can see that the half of the plane is excluded here, and you can also see that this sort of equation always has symmetry. So you can see that there is going to be a problem. But if you just plug in this expression, you can do a whole lot of algebra. You can get an answer out that looks like it's in the form that they require, and you haven't engaged in thinking about whether any of that working makes sense. And as I say, my view is you've ended up with a wrong answer. But the question has kind of pushed you in the direction of getting a wrong answer, because they've said they want something in this form, and you can't actually get anything in that form that only satisfies the lower half branch of this hyperbola. So anyway, thanks. See you next time, and hopefully NCEA will address, or NZQA will address these issues.